us take example where a massless pulley is hanging from a rigid support with the help of a massless string. There is another pulley also. All the strings, they are massless, and over here there is a mass of 5 kg, and onto this pulley there is a mass 1 kg and 2 kg connected to each other through a string. We are asked what are the acceleration of these 3 blocks. So what we do is, we can assume that is, let's say this is going down with the acceleration A in this direction. With respect to, we can say, a person on the ground. So with respect to ground, this block, let's say, is going down with the acceleration A. From here to here, we have a single string. So if we pull it by 1 meter downwards, this pulley will go 1 meter in the upward direction. So whatsoever is the acceleration of this, the same acceleration will be observed of this lift in the upward direction by this person. Now let's talk about the tensions in the string. Let's say in this string there is a tension T. This whole is one string only. We know that string is massless, so the tension will be same throughout the one string. So it means tension in this string is also T. We have also done, that is, when the pulleys they are massless, the tension in this central string is going to be double of the tension in the sideways strings. So it means if tension T is here, tension T is here, in this string the tension is going to be 2T. From here to here, this is a single string, and in one string there is one tension, so here also the tension is going to be 2T. Now let's draw the free bodies of this block. First let's draw the free body of this block. Over here we have a force which is acting this way, that is weight of the body, that is 50 Newton. And over here it is 2T is the tension in the outward direction we have done. That is, when we take the free body, we consider free body tension is always outwards. So equation for this is 50 minus 2T. We are using net force equal to mass into acceleration. So 50 minus 2T, 50 it is accelerating downwards, we have taken it. So 50 minus 2T is the net force, is equal to mass is 5 into acceleration. So this is equation 1 we get. Now we can make use of non-inertial reference frame or accelerating frame to make the things much easier. What do we mean by this? This means, let's say we put it in a lift. This pulley, which is having masses 1 kg and 2 kg on its two sides, we have put it in a lift. And we have put an observer also in the lift. So this is our accelerating observer, accelerating reference frame, who is stationary with respect to lift. So whatsoever the accelerations they are going to be observed by this person, the same accelerations are of these two blocks with respect to lift. That is one and the same thing. So this person makes an accelerating reference frame. This person sees within the lift, he sees that his 2 kg block will go down, that is, let's say, with the acceleration A dash. So this is the acceleration A dash of 2 kg block as seen by the lift or as seen by a person in the lift in the downward direction, because this is heavier. So obviously with respect to him, if this goes with A dash in the downward direction, so this will go up with A dash in the upward direction. Now if he wishes to apply the laws of motion, Newton's laws of motion, so in addition to all the real forces we have done, that is, he has to consider one more force, that is what we call as pseudo force, fictitious force, imaginary force. And the direction of this fictitious force, imaginary force, pseudo force is opposite to the direction in which this observer is accelerating. This observer is accelerating in this direction with the lift with the acceleration A. So he will apply a forces in this direction onto this, that is mass into acceleration. Mass of this and acceleration of himself, that is that of lift, in the downward direction. Similarly, that pseudo force onto this is mass of this 1 into acceleration of the lift, that is A. Obviously, that is, we also know that is real forces which are acting, that is, he cannot disturb those real forces. We have drawn a circle, so that now we can draw the force diagram. Other forces also we can draw. So T is outwards, over here T is outwards. Mg is acting in this direction, that is 1 into G. We are taking G is equal to 10 meter per second square only for the ease of calculations. Otherwise, in examination, in your worksheets, etc., you have to take G as 9.81 meter per second square. You can take G as 10 meter per second square only, that is, if it is specified. So over here the weight of this 1 kg block is 1 into G, that is 10 Newton. And that of this is going to be, that is 2 into G, that is 20 Newton. Now let him make the equation. Now he is competent to make the equations. This person who is an accelerating reference frame, he has drawn all the real forces. In addition to all the real forces, he has also drawn the pseudo forces also. So now he is competent to apply laws of motion. Let's make the equation for this. What is the equation he makes for this? He sees that is this block goes up, so upward forces minus downward forces. Upward force is T, downward forces is 10 Newton plus 1A, that is pseudo force, is equal to, he observes this going up with the acceleration A dash. A dash is the acceleration of these two blocks as seen by this person. So it is mass into acceleration. So this is equation number 2. This person sees this block going down with the acceleration A dash. So the equation comes out with downward forces minus upward force. 20 Newton is downward force plus one more pseudo force, that is 2 into A. So 20 Newton and 2A, they are the forces in the downward direction, minus T, that is force in the upward direction, is equal to mass 2 into A dash. So this is third equation. So if you see, that is, we have three equations, equation number 1, equation number 2, equation number 3. So to find the values of T, A and A dash, we have three unknowns. To solve for three unknowns, we need three equations which are already here. So we can use these equations to get the values of A dash and T. So once we make these equations, then we can easily solve it. The value of A as 70 by 23 meter per second square. We can put these values over here to get the answers, all the answers A dash T, and this way we can solve this question.